Visible.
Good morning, everyone present here. Here, my topic is SIFCON concrete, and I'm going to explain about it. Uh, SIFCON full form is slurry infiltrated fibrous reinforcement concrete. It is actually a kind of steel fiber reinforced concrete and can be considered as an high performance concrete. The usage of steel fiber with cement with Portland cement was started in 1968, and in 1979 it is proved that the percentage of steel in fiber in cement matrix that when it is increased, it would have very high strength properties, and it is designed in the name as SIFCON. One second, sir. Uh, the strength of the concrete is high with the flexural strength, and it is very useful in earthwork areas. Actually, initially, when in SIFCON, the cement slurry is introduced over the steel fibers. The coarse aggregate is actually completely omitted, and here the fine aggregate used is only used with the cement. That is actually sand and the additives like sand, fly ash, coarse sand it is used, and additives like fly ash, microsilica are used. When adding this admixture, we have to be very careful because sometimes it may not be filled properly, and it would lead to large pores where the property is reduced. Property means the SIFCON special properties. Which can be reduced. So, and superplastizers can also be used for improving the flowing characteristics. SIFCON normally has very high duct. It is very high in ductile, and it also has a very high strength. During any abnormal condition, like for example, during heavy loads, crack may also form. But here in SIFCON, the cracks may not be formed due to the fiber interlocking. Fiber interlocking means the fiber holds the fiber actually holds each other very tightly, and it also result in the reduction of cracks. So the stress strain properties can also be reduced. Uh, the steel fibers may be actually it is hooked or crimped during the interlocking. It can be either mechanical and frictional interlocking in the bond. So the shear will also actually reduces and also acts as bearing to keep the fibers interlocked. This is a composition of SIFCON. The cement and sand are in the proportion of either 1:1 or 1:2 or 1:1.5. Cement slurry, actually. The fly ash is the additives such as fly ash or the silica can be of 10 to 15% of the weight of cement used in the mix. Water cement is of 0.3 to 0.4. The percentage of plasticizers can vary from 2 to 5% depending upon the weight of the cement. The percentage of fibers can be very anywhere from 4 to 20%. Normally in FRC, it will be very less, but in SIFCON, the percentage of fibers will be very high. Actually, 4 to 20%, because the current practical ranges is only from 4 to 12%. The process of making SIFCON. The SIFCON actually first initially in the mold of formwork, the SIFCON is actually placed inside, and then only the slurry is mixed with it, because normally in steel fiber reinforced and concrete, the steel fibers are mixed with the concrete directly and then poured into the formworks. But in SIFCON, the steel fibers are first packed and then the slurry is poured into the forms or molds. These are the factors affecting the efficiency of SIFCON. The four factors that considered are slurry strength, fiber volume, fiber alignment, and fiber type. Slurry strength plays the major role because the concrete is mainly depending upon it. It is fully made of cement slurry. It is a backbone for the specimen. The elastic moduli tensile and compressive strength will be affected if there's a problem in if there's problem in the cement slurry. Fiber volume. Fiber volume depends upon the fiber type and vibration effect, because shortened fiber than longer fibers can be added will add extra vibration time. So the fiber volume must be achieved by adding equal amount of short fibers or long fibers. Fiber alignment greatly affects the behavior of the SIFCON material, because the fiber, if there's a randomly oriented, means it will not be good, because it would be not be well. It must be aligned normal to the loading or parallel to the loading. It must not be in random. The strength, ductility, and energy would be dependent upon the fiber alignment. Fiber types are of two types. Yeah, steel fibers and glass fibers. Steel fibers comes in main three shapes and several sizes and strength. The shapes may be, as I said before, it may be of hooped or crimped, and it may be in various aspect ratios. The most popular steel fiber used in SIFCON is Dramix fiber. Glass fibers would actually be generally rod-like in shape with various length and diameters, but generally steel fibers are only used. Glass fibers are not used that much frequently. As I said, SIFCON is better than FRC in these conditions. The strength of SIFCON is better than fiber reinforcement concrete. In FRC, there is a risk of balling and clustering, but in SIFCON, it is actually reduced. The fiber content in FRC is limited just to 2 to 15%, but in SIFCON, it is considered with till maximum 20%. The SIFCON actually possesses a high flow and passing ability than FRC. The advantages, SIFCON has greater durability, energy absorption capacity, impact and abrasion resistance and toughness. Modulus of elasticity for SIFCON is more when compared with plain quality. Again, same high ductility. The limitation is steel fiber reinforced. I said balling problem in SFRC would increase, and it is overcome by SIFCON. In that only I said in the previous slide that balling and clustering would happen in FRC, but in SIFCON, it is actually it overcomes the problem. The deflection also for SIFCON would be very less. Disadvantage. In spite of so many advantages, it also has some disadvantages. It cannot be applied in hydraulic structures, and the fibers may also corrode. So corrosion inhibitors may be necessary. The cost of construction is actually high if the fiber usage is more, and also the fiber type is costly. It may be high. It needs a good compaction and supervision. The properties of SIFCON, like the same ductility, characterization, and impact resistance is very high compared to SRFC. It may be used in pavement rehabilitation and precast products. It can be used in bridge decks. It, as I said before, it is a earthquake resistant structure. So seismic and explosive resistant structures as a SIFCON can be used. Security valves can also be built using a SIFCON. Military applications such as anti-missile hangars and underground shelters can also be used. It is used in aerospace. It is used in any repairing or rehabilitation of any structures, and it also used to strengthen the structures if necessary. Thank you, sir. Thank you, sir.
Thank you. Thank you, Gautam. Anyone having doubt? Doubt?